Hey friends, and welcome back. Today we are going to have a look at IFC CSV together with Dion Moult.
Thanks, Petru. So as a quick introduction, IFC CSV lets you take data that comes from an IFC model, like the one I have already loaded up in my screen, and it will export that data into a spreadsheet form. So that spreadsheet could be a CSV file, it can be an open document spreadsheet file, or it can be an Excel spreadsheet file, or if you are using IFC CSV as a programmer, you can also get a pandas data frame. And the thing that all of these formats have in common is that they are spreadsheets or tabular-like data, headers and rows. So this is a feature that almost every single BIM tool has. Most BIM tools have some sort of spreadsheet-based import-export, and this is exactly the same thing, except it works with native IFC. So if you want to use it graphically, you can do it through the BlenderBIM add-on, and you switch over to the Quality and Coordination tab over here, and you can click under Collaboration, Spreadsheet, Import, and Export. So after you've exported it, you can also edit those properties in a spreadsheet application, and then you can import that back into IFC. So you can browse to the IFC file that you want to get some data out of using here, or because we already have one loaded over here, we can just press load from memory. So in order to specify the data that you want to export, you first need to create a search filter of the types of objects that you want to export. So let's say we want to create a schedule of all of the construction types used in our projects. So I can add a filter called a class filter, and I can type in IFC type product, and that will bring in all of the types that I've defined in my project. And I can also go and add a single attribute that I want to extract from all those types. And by default, it pulls up the class of those types. And now let's add another attribute. So you can think of these attributes as the columns in your table. So we'll have one column for the class. We'll have another column for the name. And you can see that this is split into two halves. The first represents a query of the type of data you want to extract. And this represents the header that you'll see in the table. So class with lowercase c is a query, and IFC class is what you'll see in a spreadsheet. In this case, name is a attribute query, and if I delete that, say it's optional, it will use the exact same value as the header over here, as the query for the header. So let's press export, and let's take a look and see what that looks like. So here it is. You can see that by default, IFC CSV actually injects a first column known as the global ID column. And you can see that this long list correlates to the list that you can see on the left side of my screen. You can see all my beam types, my column types, and so on. So for this beam type, if I go to the object properties, I can see a global ID that correlates to, in this case, that one, this beam type. And I can also see that the name of that beam type, B1, correlates to this, and the class correlates to IFC beam type. So that's it in a nutshell of how you might use it. There's a whole bunch more settings you can do, of course. So let's take a tour. First, we'll take a look at some of the filters you can add. You can continue to specify class filters. So if I only wanted wall types, I can just change that to IFC wall type. And now I will only export out the wall types in my schedule. Or I can specify I want all wall types with an attribute name set to wall 100. Now this is a bit of a boring schedule because there's only one wall named wall 100, but that will show you how we can do that type of filtering. So you can filter on a whole bunch of different types of things. We've seen the class and the attribute, but you can also filter on the presence of property sets or properties in those property sets, as well as materials. So you can say that I want all walls made out of concrete or all beams made out of steel. You can use classification systems. So if you use systems like OmniClass or Uniclass, you can use that. Or a location. So I can say that I want all walls on my story. So let's try location. I'll remove this and I'll change this to IFC wall, simply because wall types don't have a location. It's the walls themselves which have locations. And we'll say it's located on my story. And there we go. Here are all my walls located on that story. Then, of course, we can filter occurrences or instances of objects by the type of object. And you can also specify a custom query. And this is for more advanced users, which we'll go into a little bit later on in this video, or a global ID where you can arbitrarily specify IDs or use a picker to visually select certain elements that you want included. So let's try that out. So there you go. Here are the walls that I've just selected, which you can see correlates to the selection over there. So now let's take a look at a couple of settings you can tweak. You can also change the type of format you want. We can also change the delimiter if you live in a particular locale which uses a different delimiter. If you have a null value, you can specify how to represent that null value. Or if you have an empty string, so many software don't differentiate between these, but if it did, you can go and specify how you want empty strings to be displayed, and Boolean values like true and false, you can specify it to say different things like yes or no. So instead of saying, is load bearing true, you would just say, is it load bearing? Yes, which is a bit more friendly to read if you want to put the schedule on a sheet later on. And of course, you can remove this, the global ID column if you want to put it on a sheet as well. But the downside is then you can't import it back in because the global ID is used to do this round trip data manipulation. So let's take a look at a query I prepared earlier. It's like a cooking show. So I have this settings.json. So I should probably mention you can save and load settings for your spreadsheets. So over here, we're going to create a schedule of all walls and slabs. And we're going to have 3 columns. The first is the class of the wall and the slab, followed by the name of the wall or slab's type, and then followed by a funny looking query, which we'll take a look at shortly, which shows the gross volume quantity of that wall or slab. So let's spit that out. And there you go. So here we have a bunch of walls. We have 1 slab, and you can see that we've got 1 wall of this wall type, and the rest are this 200 millimeter thick wall. And we have the gross volumes for all of them, currently in meters squared. So now we can do a few tricks. So for example, we can do a simple sort on this. We can make it sort ascending or descending. So if you want to sort it by the gross volume ascending, we can over here change that to be ascending. And then there you go. You can see it's now ascending. And we can also apply grouping rules. So for example, we can say that we want to group the schedule by the type of object. So I can say that this is now what I'm grouping on. And you can group by multiple columns, and they all have to be unique to match this unique key for grouping. And now I can say what happens to other columns when they are grouped. So for the gross volume, I want it to be summed, and I want the sum of the volumes that are all aggregated together into a group. So let's see what that looks like. So there we go. We have this much volume of this wall type, this much volume of that wall type, and this much volume of that wall type. And you can also specify a summary row. So if you want a kind of a total summary at the very end of it, you can also specify what type of summary calculation you want to perform. So let's create a sum of all the gross volume. And I might also remove the global ID to make that look like a more reasonable schedule. There we have it. And you can see the sum at the bottom. And now finally, a cute little trick you can do is apply a custom formatting rule. So there is a special formatting language you can use to further customize how these things are shown. So if you want to round it to the nearest, 5 or 10 or 0.1, or if you want to format it using imperial formatting rules, or for example, what we're going to do here is rather than saying IFC wall, let's change that to cut out a substring to just call it a wall or a slab to make it less, more readable for non-BIM geeks. So we can say substring, and we'll use the first 3 characters, and let's do that. And now you can see it just says slab wall, which is much nicer. So I do want to touch a little bit on this funny query here. You'll notice that, there's some weird characters in here. And the reason for that is that we're actually pulling out a quantity from our objects. And if we go back to our object properties, you can see that we have this quantity takeoff wall-based quantities, and we have quantity takeoff slab-based quantities, and they all hold a whole bunch of different types of quantities. But the quantity name is consistent. such as gross volume. Now, if we want to fetch the property gross volume regardless of the name of the quantity, we can use what's known as a wildcard search. So you know when you search in things and use an asterisk for a wildcard, you can do that type of similar wildcard search. This is known as a regex search or a regular expression search. And you do that by specifying the quantity set name in forward slashes, and then over here I can say, this says that match any character in between quantity and base quantities. And that allows me to have a schedule that pulls out data from different types of quantity sets, both wall-based quantities and slab-based quantities. So the last thing I'd like to leave with is a bit of documentation. So one thing you'll have to do if you want to use this effectively, is that you'll want to learn how to write these queries, or perhaps how these filters work in a little bit more detail, or if you want to write advanced queries, how to use this query filter, as well as how to use this formatting language. So that is all documented in, not here, there we go, in the IFC OpenShell documentation. If you go under IFC OpenShell Python, under selector syntax. So this gives a bunch of examples of how the filtering system works if you want to write custom filter queries, and it gives a whole bunch of examples. So if you want any doors named DO1, or I want all walls or slabs except one particular element that has a material of concrete and a 2-hour fire rating, these types of funny queries. And it shows how to write it, as well as a detailed breakdown of the different types of syntax you can use. And it gives an example of each one. So you can say, you can even do things like find me all types that have only a single material layer. I don't want multiple material layers. Or find me all types that don't have any instances or occurrences used in the project, something like that. Finally, here are the queries if you want to write in queries over here. It gives a few example queries with some descriptions of what they mean, as well as a list of things you can use to construct your own queries. And then finally, we have a whole bunch of formatting rules. So this shows how you can do things like make everything uppercase or lowercase, or concatenate values or round values, and so on. And that's pretty much it, I guess. I hope this has all made some sense, and enjoy.
Well, this was amazing, Dion. Thank you very much. Now, the only thing you need is to make sure that you export all the data that you create in other software if you are using any other authoring tools, right? And then knock yourself out using IFC CSV. But now maybe we should change the name to IFC Spreadsheet. Thank you very much. Really appreciate it. This was amazing. I can't wait to start using this.
No problem. Thanks for having me.
Thank you for joining me, Dion, and for doing this.